3D printing. 3D printing or additive manufacturing is a process of making three-dimensional solid objects from a digital file. The creation of a 3D printed object is achieved using additive processes. In an additive process, an object is created by laying down successive layers of material until the object is created. Each of these layers can be seen as a thinly sliced cross-section of the object. 3D printing is the opposite of subtractive manufacturing, which is cutting out, hollowing out a piece of metal or plastic with, for instance, a milling machine. 3D printing enables you to produce complex shapes using less material than traditional manufacturing methods. It all starts with a 3D model. You can opt to create one from the ground up or download it from a 3D library. There are many different software tools available, from industrial grade to open source. We've created an overview on our 3D software page. We often recommend beginners to start with Tinkercad. Tinkercad is free and works in your browser. You don't have to install it on your computer. Tinkercad offers beginner lessons and has a built-in feature to export your model as a printable file, e.g., STL or OBJ. Now that you have a printable file, the next step is to prepare it for your 3D printer. This is called slicing. Slicing basically means slicing up a 3D model into hundreds or thousands of layers and is done with slicing software. When your file is sliced, it's ready for your 3D printer. Feeding the file to your printer can be done via USB, SD or Wi-Fi. Your sliced file is now ready to be 3D printed layer by layer. Adoption of 3D printing has reached critical mass as those who have yet to integrate additive manufacturing somewhere in their supply chain are now part of an ever-shrinking minority. Where 3D printing was only suitable for prototyping and one-off manufacturing in the early stages, it is now rapidly transforming into a production technology. Most of the current demand for 3D printing is industrial in nature. Acumen Research and Consulting forecasts the global 3D printing market to reach $41 billion by 2026. As it evolves, 3D printing technology is destined to transform almost every major industry and change the way we live, work, and play in the future. 3D printing encompasses many forms of technologies and materials, as 3D printing is being used in almost all industries you could think of. It's important to see it as a cluster of diverse industries with a myriad of different applications. Companies have used 3D printers in their design process to create prototypes since the late 70s. Using 3D printers for these purposes is called rapid prototyping. In short, it's fast and relatively cheap. From idea to 3D model to holding a prototype in your hands is a matter of days instead of weeks. Iterations are easier and cheaper to make, and you don't need expensive molds or tools. Besides rapid prototyping, 3D printing is also used for rapid manufacturing. Rapid manufacturing is a new method of manufacturing where businesses use 3D printers for short-run, small-batch custom manufacturing. Car manufacturers have been utilizing 3D printing for a long time. Automotive companies are printing spare parts, tools, jigs and fixtures, but also end-use parts. 3D printing has enabled on-demand manufacturing, which has led to lower stock levels and has shortened design and production cycles. Automotive enthusiasts all over the world are using 3D printed parts to restore old cars. One such example is when Australian engineers printed parts to bring a Deluge Type C back to life. In doing so, they had to print parts that were out of production for decades. The aviation industry uses 3D printing in many different ways. The following example marks a significant 3D printing manufacturing milestone. GE Aviation has 3D printed 30,000 cobalt chrome fuel nozzles for its LEAP aircraft engines. They achieved that milestone in October of 2018, and considering that they produce 600 per week on 40 3D printers, it's likely much higher than that now. Around 20 individual parts that previously had to be welded together were consolidated into one 3D printed component that weighs 25% less and is 5 times stronger. The LEAP engine is the best-selling engine in the aerospace industry due to its high level of efficiency, and GE saves $3 million per aircraft by 3D printing the fuel nozzles. So this single 3D printed part generates hundreds of millions of dollars of financial benefit. GE's fuel nozzles also made their way into the Boeing 787 Dreamliner, but it's not the only 3D printed part in the 787. The 33-centimeter long structural fittings that hold the aft kitchen galley to the airframe are 3D printed by a company called Norsk Titanium. Norsk chose to specialize in titanium because it has a very high strength-to-weight ratio and is rather expensive. meaning the reduction in waste enabled by 3D printing has a more significant financial impact than compared to cheaper metals where the costs of material waste are easier to absorb. Rather than sintering metal powder with a laser like most metal 3D printers, the Norsk Merc 4 uses a plasma arc to melt a metal wire in a process called rapid plasma deposition, a form of directed energy deposition, that can deposit up to 10 kilograms of titanium per hour. A 2 kilograms titanium part would generally require a 30 kilograms block of titanium to machine it from, generating 28 kilograms of waste, but 3D printing the same part requires only 6 kilograms of titanium wire. Is it possible to print a building? Yes, it is. 3D printed houses are already commercially available. Some companies print parts prefab and others do it on-site. Most of the concrete printing stories we look at on this website are focused on large-scale concrete printing systems with fairly large nozzles for a large flow rate. It's great for laying down concrete layers in a fairly quick and repeatable manner. But for truly intricate concrete work that makes full use of the capabilities of 3D printing requires something a little more nimble, and with a finer touch. When we first started blogging about 3D printing back in 2011, 3D printing wasn't ready to be used as a production method for large volumes. Nowadays there are numerous examples of end-use 3D printed consumer products. Adidas 4D range has a fully 3D printed midsole and is being printed in large volumes. We did an article back then, explaining how Adidas were initially releasing just 5,000 pairs of the shoes to the public, and had aimed to sell 100,000 pairs of the AM-infused designs by 2018. With their latest iterations of the shoe, it seems that they have surpassed that goal, or are on their way to surpassing it. The shoes are available all around the world from local Adidas stores and also from various third-party online outlets. The market of 3D printed eyewear is forecasted to reach $3.4 billion by 2028. A rapidly increasing section is that of end-use frames. 3D printing is a particularly suitable production method for eyewear frames because the measurements of an individual are easy to process in the end product. But did you know it's also possible to 3D print lenses? Traditional glass lenses don't start out thin and light, they're cut from a much larger block of material called a blank. About 80% of which goes to waste. When we consider how many people wear glasses and how often they need to get a new pair, 80% of those numbers is a lot of waste. On top of that, labs have to keep huge inventories of blanks to meet the custom vision needs of their clients. Finally, however, 3D printing technology has advanced enough to provide high-quality, custom ophthalmic lenses, doing away with the waste and inventory costs of the past. The LuxExcel Vision Engine 3D printer uses a UV curable acrylate monomer to print 2 pairs of lenses per hour that require no polishing or post-processing of any kind. The focal areas can also be completely customized so that a certain area of the lens can provide better clarity at a distance while a different area of the lens provides better vision up close. There are 2 ways of producing jewelry with a 3D printer. You can either use a direct or indirect production process. Direct refers to the creation of an object straight from the 3D design, while indirect manufacturing means that the object, pattern, that is 3D printed eventually is used to create a mold for investment casting. Like, comment, share and subscribe to my channel.